Today we're talking about division properties of exponents. So we can use repeated multiplication to simplify fractions. That would mean 5 to the 6th power we've expanded the numerator and denominator, and we can cancel the like terms. So this would equal 5 to the 4th power. This example illustrates the property of exponents. So the property of dividing powers with the same base says that for every non-zero number a, an integer m and n, a to the mth power divided by a to the nth power is equal to a to the m minus n. So let's try an example. For example, if we have 3 to the 7th power divided by 3 cubed, this is equal to 3 to the 7th minus 3, in other words, 3 to the 4th power. This is using the property. If we try this using repeated multiplication, three to the 7th power and 3 cubed. 1. See how this is equal to 3 to the 4th power. If we have to simplify c to the negative 1 times c cubed divided by c to the 5th power d to the negative 4th power. If we have to subtract the exponents of the common bases, this means c negative 1 minus 5 d cubed minus negative 4. This is equal to c to the negative 6 d to the 7th power. Now we have a negative exponent. To make a negative exponent positive, in this case we would put it in the denominator. We can use repeated multiplication to simplify x over y to the 3rd power. This would mean x over y times x over y times x over y, and this would equal x cubed over y cubed. We can use this example to illustrate another property. The property raising a quotient to a power says that for every non-zero number a and b, an integer n, a over b to the nth power is equal to a to the n over b to the n. For example, if we have 4/5 to the 3rd power, we have to distribute this 3 to both the numerator and denominator. This will mean 4 cubed over 5 cubed. And then we can evaluate, so 4 cubed is 64 and 5 cubed is 125. If we have 4 over x squared raised to the 3rd power, we would distribute to the exponent. This would mean 4 cubed over x to the 6th power, which would equal 64 over x to the 6th power. If you have 3 over 5 raised to the negative 2 power, we distribute the negative 2 exponent. We say 3 to the negative 2 power over 5 to the negative 2 power. Now, in order for us to evaluate the negative exponents, we have to make them positive. So the negative exponent in the denominator, we bring this power to the numerator, so it's 5 to 5 squared, and we bring the negative power to the denominator, 3 squared, and now we can evaluate and say 25 over 9. Could we write this improper fraction as a mixed number? We can write it as 2 and 7/9. Let's try another one. Let's say you have 2x over y raised to the negative 2 power. We distribute the negative 2 exponent. This would equal 2 to the negative 2 power, x to the negative 2 power, and y to the negative 2 power. We make all the negative exponents positive. This would be y squared over 2 squared x squared. This equals y squared over 4x squared. I'll give you one more example. Let's say we have 4/8 x to the negative 3 x to the negative 12. Can we simplify this? What happens with the 4 and the 8? Do they have a common base? They have a common base? No. So the only thing we can do with 4 and 8 is simplify them. 4/8 simplifies to 1/2. Now the x with the negative exponents, what is the rule when we're dividing exponents with the same base? Subtract the exponents. So we would say x to the 9th power over 2